Okay, hello, thank you for having me here and for joining my speech. It's my first time in the United States, and I'm really excited to speak at this amazing conference. So, yes, as Elena said, I'm going to talk about how I use machine learning for language learners. So, about me, I am from Ukraine. It is in Europe, near Poland. Not too close to Portland, but yes. I'm from Kiev. It's a screenshot from Simpsons show. So I like this picture, simplified picture of my city. My English teacher said it's some American joke, you will understand. Okay. So about my career, currently I'm working as lead big data engineer in EPAM systems, and also I'm founder of Tutor Translate. It's my startup. And before that, I worked in a couple of companies in Kiev. So I started with Java and related technologies like Spring, Hibernate, relational databases, but several years ago I switched to distributed systems and Scala and related technologies like Spark and other big data stuff. And also my everyday technology I use is Stack Overflow. Yes. Okay, agenda for my speech. I will describe what is Tutor Translate. I will tell you how it applies machine learning. I will tell you about text classification and logistic regression algorithms, and we'll show their implementation with Apache Spark, and then collaborative filtering, and also demo with Spark. Okay, so what is Tutor Translate? It's my startup. It is alpha released. This cloud notebook for translations. It allows users not just to translate text, but also to remember the translations, collect them, and manage. For example, I will show you a quick presentation. Unfortunately, it is not adapted to mobile phones for now, but I hope it will be in the recent future. Okay, let's register. So we have a workspace here and one default word. It's hello in Ukrainian. We can translate words manually here, for example, from English to any language. I learned English, so I translate to Ukrainian, but I assume you know English already. So you can choose another, like German or Italian or Spanish. So let's translate some text with extension that is available in Chrome. For example, on and any web page like like in Wikipedia, we just select word and have translation. Yes, it works like this. So after that, we can back to our account, and all these words already here. And we can see details with context and with link where it was translated. Please remember these terms. There's a source where it was translated and the context, the part of sentence where this word was met. So which problems I solve here? I've solved the recommendations of new articles to users. So for example, based on their translation history. And I recommend new words to users. So to recommend articles, I use logistic regression because I need to detect the topic of the context. I will dive into details later. And for new words recommendation, I use collaborative filtering. So let's talk about classification. What is this? So classification identifies to which of category a new observation belongs. It uses training set of data with known categories. So we tell them, for example, this text has a topic of music, or this text has a topic of finance, so we teach the model. For example, we say to algorithm, these are puppies, these are kittens, these are baby raccoons. So after that, our algorithm should answer the questions, who is this? When we have multiple categories, we apply logistic regression to, what is logistic regression? Okay, it is implementation of classification. It is supervised algorithm, and it means that we need to train it with data before using. It classifies some category. Is this object belongs to this category or no? And for multiple categories, we should apply this logistic regression for each of them. This is logistic function, but you don't need it to make money. Okay. So, for example, we have 3 categories, and we apply logistic regression for one of them. For example, are these dogs? Yes or no. Are these cats? Yes or no. And are these raccoons? So, about recommendations of new articles, this is the flow. We need to detect translation topic of a context of a word, then find sources with these words in other users. For example, if other users also translated the words you translated, we need to find that links and find the most relevant link. So let's see an example. For example, we have translation histories of 3 users, and we want to recommend some new articles to the first user based, for example, on the word as emphasize that he translated. So we can notice that other users translated the same word. So we need to take their articles, their sources. But could we recommend all articles just because they translated the same word? No, because this word could be in different texts, in different topics. So we need to detect topic of that sources using classification algorithm. So we classify, and for example, we detected that here we have 3 topics: science, science, and music. And obviously, we will not recommend music topic to first user because he translated it on the science web page. So after additional filtering like whitelist and robust.txt, for example, to not recommend private documents on Google Drive, we can say that we recommend source to first user. Okay. We use Apache Spark for this. Apache Spark is a framework for distribution calculations. It consists of several modules, but we are interested in ML module. Before it was MLlib, but MLlib is deprecated now, so we use ML, machine learning. So let's look at typical workflow for classification algorithms. First, we split data into 2 parts. Like, for example, we have a lot of text, and we want to train the model. So we split our text into 2 parts: training data and testing. So with training data, we load the data and extract features. For example, we have several texts. One of them is about music, the second about finance, the third about politics. And we trained the model. We said, listen, read this text, it is about music, just remember. Read this text, it is about finance. And then using testing data, we just test our model for the accuracy. So what is features? For example, how to extract? We extract features from the first picture. For example, it has elongated face, and it is tricky, it has black mask around the eyes. And this has round face and no black mask around the face. So we send this information to our model. It is model training. And then when we ask with a new picture to model, it will extract features and compare with what this model knows, and will tell us the result. Okay, Spark pipeline. Spark pipeline is a flow of data modification we need to do to train a model. So first phase is indexer. For example, when we train model with some large texts, we need to label it with topics, but Spark doesn't use text words, it uses indexes. So indexer just replaces text with indexes. For example, we have different text with that topics labeled, so we just need to replace words with indexes like here. Then we use tokenizer to split our text into arrays of words. For example, this text, and we split to arrays of words like this. Then we apply stop words remover to filter some not very useful words like articles or prepositions. For example, we have such text, and after apply stop words, we have this. So there is no such words as was, a, or who. And then TF IDF. It's TF, for example, it's term frequency. We need to detect the frequency of each term in the text. And for example, we loaded some text, and we detected that this is the most frequent words in the text. But as, for example, if stop words remover didn't filter all not useful words, we use TF IDF. So as you can see, it's not very informative words because they are all in all text. So after that, we need to apply inverse document frequency. It will detect how much the word is valuable among all documents. So after applying IDF, we will receive something like this. And we will know that this text about space and these words are useful for us. Then actually we apply logistic regression and back return our topic readable names. So let's see a code. These are Spark classes, implementations of all of these phases. Okay, so I will use Apache Zeppelin. It's a notebook for running code in convenient way. Okay, so this is simplified implementation. It is written in Scala language. If you don't know Scala, Apache Spark works with Java, Python, R, so you can choose the language. So here we import required classes. This is specific Spark objects like context, configuration. Then we load files from GitHub. They're not very large. They are small texts. I intentionally choose them for presentation to run on a simple laptop. So, for example, I will show these texts. This is a text machine learning. Here are different texts, different sentences collected from Wikipedia or some free electronic books. And this text about music also from Wikipedia and articles in the internet. So we load these files and create data frames from them. Data frame is structured, resilient distributed data set. It means that it is distributed among Spark workers. So, and we add column to each of these texts with label. For example, we loaded machine learning file and we marked it as machine learning, and also for space and music. Okay, so let's see what we have. We have this text, different texts, split it into lines, and we have label. Yes, labels of each of these texts. Then, as I said before, we initialize such classes as string indexer to replace labels with indexes, then back index to string, regex tokenizer to split words, stop words remover, TF IDF to extract features, and finally logistic regression implementation in Spark. So we need to tell him this indexed label column and set the output column of features. Also, it has such parameter as max iterations and regression params, but they choose experimentally. I will not describe you here how to do it because it's separate speech. And finally, we construct pipeline of these phases. And after that, we split our data into training and test, 80 and 20%. Why such splitting? Because we need a lot of training data to train models, so it's 80%, and only 20 to test the accuracy. So finally, we have this our model after we fit it into pipeline. And let's see how it works. So we transform our, for example, test data with our trained model, and we will see results in prediction label column. So this is predefined labels that we marked at the beginning, and this is prediction label, which our algorithm predicted. So we can see that accuracy is quite good. To tell more precisely, we will use evaluator. It will tell us the accuracy of our model. So it is about 80%. Not very good, but not bad as for presentation with small amounts of text. So finally, let's back to our real world example. We load this text, this file with users' translations. Let's see that file. Okay, so we have 4 users, 1, 2, 3, 4. We have their words that they translated, and we have, sorry, it's, yes, we have words, contexts, and sources where it was translated. So we load this information to our Spark data frame, and then we want to predict what we want to recommend to new user. So these new translations, for example, of a user, we want to recommend him or her articles. So, for example, he translated words reason with this context and word related with this context. So what we can recommend to these users? We need to detect topics of previous users' translations. For example, let's see what we have, how it was detected. So we have these context with reason-related words. And looks like it works because it predicted text about Apollo 18 as space, about Australia economy as finance, and also other texts as machine learning and music. So let's back to words we want, the user we want to recommend. So we detected that this user translated words, reason and related, and these contexts have the following topics, namely space and finance. So we need to filter that sources that have this space and finance topics, namely these. To do this, we will use simple join by word and prediction label. And finally, we have results. So we will recommend to that user these sources. And this user will receive something like this via email. So it was the first example of the first solution. Let's back to our presentation. The next problem, we will use recommendation of few new words using collaborative filtering. Claire from GitHub already mentioned this algorithm today, so I will repeat. This algorithm learns without explicit information about user, but it uses interaction between user and products. For example, we have two cases. We want to recommend a restaurant nearby your location, and also we want to recommend songs based on other users' tastes. So how do you think where we can apply collaborative filtering? So we cannot apply it here because it uses explicit information about user, its location. But collaborative filtering will be applied here because here we know only what user bought which songs. And in our case, we will find users which translated same words and will recommend just their words, which, for example, I didn't translate. Let's see. For example, we have 4 users, and we have the count of words which they translated. For example, first user translated word achieve once, emphasize twice, etc. So what we can notice here? We can notice that these users have common words. So intuitively, we can say that first occur, we can recommend to first user, and first explicitly, word explicitly, we can recommend to second user. But algorithms, unfortunately, it doesn't have intuition. They need precise algorithms and mathematics. So we can present this information in this form, like form of matrix. And for simplicity, let's replace our numbers with ones, because it doesn't matter in this case. So what we want to do? We want to predict these numbers. So if it's 1 or near 1, if greater than 0.5, so we can recommend this word to user. If it is about 0, we will not recommend. So, for example, Apache Spark uses non-negative matrix factorization algorithm. Don't be afraid. It is implemented in Apache Spark under the hoods, so you can just read about it later. I will recommend useful sources, but I will explain briefly. So this algorithm transposes, split that matrix to two new matrices with extracted features. So after multiplying these matrices, we will receive the results, and we will know that we can recommend these words with red ones, and with 0 we can't recommend. So let's see again to the code. Let's choose other. Okay, we don't have time. I will briefly explain. I already talked about this. It's importing of classes, Spark context, loading files. There's several files with words, words aliases, but the main class, the main file we need is user word count. I will show you it. So here it is. Here's user ID. This is words ID and the count, how much this word was translated by that user. And after filtering for bad words, for filtering like is this that words present in English dictionary, finally we feed that information to ALS class. ALS is alternative least squares algorithm, which implements collaborative filtering in Spark. Also, these params choose experimentally. And finally, for example, we want to recommend new words to user with ID 8. So let's see what this user translated. So he or she translated these words, and we will apply our model to recommend new words to this user. So after that, we have these words that we will recommend. And this user will receive these words in such form like this, via email, with translation and examples of usage. Okay, so I want to recommend you this book if you're interested in Spark. It's Advanced Analytics with Spark about applying machine learning. And also very nice course of Stanford University. I really highly recommend it. And that's all. Thank you very much.